Our hypothesis states that if we enter an elevator and take our weight as it begins to rise or descend, then our weight will increase for a second and decrease for a second respectively.
We're going to start with our calculations of our test object at rest. We began with the initial weight of 153.8 pounds. To calculate the pounds to change into kilograms, we divided 153.8 pounds by 2.2 and got 69.9 kilograms. Next, we tried to find our force gravity, which would be mass times gravity. We timed 69.9 kilograms by 9.8 and got 85.12 newtons, which is our force of gravity.
Go.
Next is our calculations of going up in the elevator. So we started with the weight that we got, our max weight, which was 168.8 pounds. Next, we converted pounds to kilograms. So we divided 168.8 pounds by 2.2, which is 73.73 kilograms. Next, we had to find our force normal, which would be mass times gravity, which is 76.73 kilograms times 9.8, which is 751.93 newtons, which is our force normal.
In order to find the acceleration of the elevator going up, we take the net force, which is 751.95 newtons, minus 685.12 newtons, in order to find the net force, which is 66.85. We take the net force, which is equal to mass times acceleration, and in order to find acceleration, we take the net force divided by the mass, which is 66.85 divided by 76.73 kilograms, and we calculated that to be an acceleration of 0.871 meters per second squared.
Get it now.
Oh my god.
See how it drops?
Next is our calculations for the elevator going down. We started with the least amount of pounds on the video, which was 145.6 pounds. We converted it from pounds to kilograms, so we divided 145.6 by 2.2 and got 66.81 kilograms. Next, to find the force normal, we have to times the mass times the gravity, which is 66.81 kilograms by 9.8. We found 648.858 newtons to be our force normal. To find the acceleration of the elevator going down, we had to find the net force of the force normal minus the force gravity, which we had found earlier, which the initial weight was 685.12 newtons, which is our force of gravity, which we plugged in right there. And then our force normal that we found earlier for the elevator going down is 648.58 newtons, which we plugged in right there. We subtracted the two and we got negative 36.54 newtons. Next, we took the net force minus mass times acceleration to find acceleration. We rearranged that problem to get acceleration equals net force divided by mass. We took the net force divided by the mass, which we used a kilogram version of the mass of the elevator going down, and the acceleration we found out